Right, so this is TiDB series volume 2. So I'm Tomoki Ninomiya from PayPay Corporation. And actually, currently, I'm responsible for operating TiDB and managing TiDB. But previously, I was backend engineer in PayPay, and also I took care of TiDB migration from Aurora. So this time, I'd like to show our experience, not only from database perspective, but also backend perspective as well. Here is today's agenda. So first of all, let me introduce ourselves and why we use TiDB, how to migrate, and future architecture with HTAP databases. So let me explain who we are. So we are a Japanese fintech company that provides mobile application with to realize the payment with QR code. So currently, number of features are increasing day by day, and our customers enjoy various experience in our application. Listed on here, like a normal payment as well, and convenient services, including P2P money transfer, and utility bills, or things like that. So to realize these features, we are running with attached. So first of all, customers are able to make a payment via two ways. First one is online. This is like an EC site. Another one is offline, so they are able to make payments on real merchant. This means like there will be the client as a mobile application and a POS system or EC site as well. And customers are able to make payment via their own balance on our PayPay account. That means that they are able to charge balance from bank account. And also, they are also able to make a payment via credit card directly. We are running services with microservice architecture on Kubernetes. So each component, this is same as each team, owns several services applications, like attached on the right side picture. And we are using AWS and Spring Boot with Java Kotlin, and for message queue Kafka, and for storage Aura MySQL, and TiDB. So we are using TiDB on these components, and since I was in the wallet team, so I'd like to show about experience in wallet, which is the most fundamental component. So wallet is responsible for user balance management. So due to its requirement, eventual consistency is insufficient. We need to guarantee consistency. And we need to have the severe requirements for stability and performance for wallet, because the major use cases have dependencies on wallet. This means like our failure directly impacts customer experience, all of customer experience. So we launched our services 5 years before, and we kept on growing up rapidly. So actually, the picture is a little bit old, but we achieved 58 million registered users in Japan. We are providing services in domestic Japan, so it is all users in Japan. And also, we achieved 5.1 billion payments in last financial year. And we are actually keep on growing this number. So let me show you about the situation of wallet a little bit more. So we are providing core features with single Amazon or MySQL. These core features including like payments and top-ups, P2P money transfers, cashback, and get balance. Since we are providing core features, we were bottleneck in the whole PayPay system in terms of performance and stability. The cause was a limitation to commit throughput for the OLTP workload. So let me dig into the issues a little bit more. So first issue is stability. So since we have single writer in one cluster, so if we have any failure on the writer, we are able to make a failover in a short time. But since we have only single writer, all customers get impact during failover, even though this is short time. Since we are growing rapidly, so this severity increases daily. And also another perspective is performance. So since service keeps growing, this means we can understand in two ways. First one is number of users and payments are increasing. And another point is a frequent spike in traffic with promotion. Customers tend to make payment in the beginning of campaign and end of campaign, so we can expect spike in traffic. So Actually, we are able to support this traffic with scale-up of Aura cluster, but we are almost reaching the limitation of it. So another approach which is possible is make system process asynchronous. But to support our requirement, we are not able to make it for all process. So we need to identify the solution. So in order to address these issues, we evaluated several candidates like NoSQL and NewSQL, including TiDB and sharing. So due to our requirements and current situation, like we are using Aura MySQL, so we finally decided to pick up from these two options. First one is manual sharding with Aura MySQL. Another one is TiDB. So as for sharing, we have benefit that we can use same product, which is Aura MySQL. So this is a well-known product. But as for downside, we need to keep on spending a lot of development and operational costs to manage sharing. And also, we found out that we cannot guarantee all of current consistency. So we needed to change some requirements, but no time was left. And also, this is not good for services. So we have TiDB. Actually, we have operational achievement in PayPay, and also it supports automated sharing and store consistency in cluster. But actually, nothing could be perfect. We have drawback to introduce TiDB. First one is a verification effort is quite huge for databases. As I mentioned, we have already another TiDB, but those are running with quite different workload comparing to wallet. This means we need to verify the compatibility this workload. And also, we are running TiDB on self-hosted. I mean, we are running TiDB on the AWS EC2 and EBS. So high operational effort can be assumed. But comparing its drawback, we decided to go with TiDB. As I mentioned, this is not first TiDB in PayPay. So we introduced first TiDB on 2019. And next, we introduced TiDB on the payment flow. And finally, we introduced TiDB to wallet, which is most critical and heaviest workload. So right now, we are achieving that several cluster has more than 100 terabytes volume. This doesn't mean that cluster volume. This is data size of the cluster. And also, we support regional DR. And also, we are still scaling on production environment with TiDB. So let me show you how to migrate into TiDB. So first of all, we split the target application. And next, TiDB migration of the new application. And third, changing the core application for TiDB. And last, TiDB migration of the core application. Let me explain one by one. So first of all, splitting the application. The motivation was to realize that kernel release of the TiDB migration for the core application. So ideally, we should make a phased release. I mean, gradually rolling out new databases. But due to its characteristic of application workload, we needed to make a cluster switch in one shot. So we need another way to guarantee its stability. So new application for everything the core application does, like a patch version of the library, or how queries are performed, and the coding style as well. So with this approach, we can segregate features relevant to payment and mitigate the impact for the core features for the payment in case of any failure. So by this approach also, we are able to gain experience to operate TiDB with wallets. So for database team, we are able to understand the workload on wallet and what is a critical query or how much it is performed or things like that. And for developers, we are able to understand the characteristic of TiDB before going to the core application and optimize monitoring, metrics, and alert threshold. So next part is changing application. So as TiDB is designed to support the MySQL compatibility, basically we don't have to make huge change in the application. So, however, in order to enjoy TiDB fully, we should make application change for the optimization purposes. Let me show you one example. Actually, I think you've already seen about it, but yeah, one of the big change is the auto-increment ID, actually. So consequently, we eliminated the usage of auto-increment ID. So first motivation is that we migrated 2 years ago, so there is no option to use auto-increment ID. But apart from that, we are still not using auto-increment ID for new table as well for the optimization purposes. So we found out that some of our systems have a dependency for auto-increment ID. Then we broke down the requirement one by one, and we figured that we need ID increasing based on the timestamp. Then we decided to pick up Snowflake-based ID generator because in its 64 bits, it includes timestamp, so it satisfies its requirement. So this is actually the drastic change in application because ID structure change itself is quite challenging, and also we face deadlock in the other databases that use this table data with a CDC, and also another issue is compatibility with current databases. So as TiDB migration is big change, we don't want to introduce any changes with migration. We just want to change the connection into TiDB. So to realize that, we need to change the ID structure with Aura. This means like we also need to verify compatibility with Aura with the Snowflake-based ID generator. Yes. So next part is verification. We classify the verification with these 3 points. This means like how we expect the database work in this way. And this also means that how we doubt if TiDB works correctly or not. So let me explain one by one. First one is functional verification. As a first approach, without connecting application to TiDB, we try to identify equivalence in DML result with P6Py and SQDIF inspector. P6Py is a query logging framework that can be included in Maven or Gradle. And SQDIF inspector is a tool provided by PinCap to realize the data consistency verification. And it also generates fixed SQL when we hit inconsistency. So based on it, we can identify which sort of difference can be found on it. So here is the architecture of SQDIF inspector and P6Py. So we introduced P6Py on our application, but our application still connects to Aurora. But P6Py works as an interceptor, and it publishes its DML into Kafka. And we have consumer of this Kafka and write into TiDB and Aura simultaneously. Then we can compare data with SQDIF inspector. So as a result, it failed because we have 2 issues. First one is difficulty to keep all of DML. Since we have the huge throughput, we needed to use the multiple Kafka partition of it. This means it will change the order of DML. So with single partition, this is not enough to handle all query. So this is one of the issues. Another issue is we were unable to verify tables which has frequent updates. Actually, SQDIF inspector is not designed to run it on online cluster, online databases. So we tried to address this issue with using TiDB MVCC feature, but considering the effort and what we can gain, it was not a good deal. So we utilized this architecture for tables just kind of events and generally have no or few updates. So as a next, finally, we are here to connect application with TiDB. So first of all, we can assume that we can run integration test for internal components and ETE test as a whole PayPay services. This is actually what we have. But the last one is the most important because this is quite important for us, data reconciliation. So we replicate TiDB data into our data and on each environment, and we run reconcile queries several times per day. We also classify these queries to 3 categories. First one is an internal cluster. This means like these queries will verify if transaction is working correctly with TiDB. And the second one, the third one is comparing data with TiDB and other Aura clusters. So with this approach, we verify the functionality with TiDB, and we can make sure that it works as expected in comparing to current situation. So next part is performance verification. This is the most exciting part, actually. So we build TiDB and prepare production compatible data on it. And we confirm that performance is dramatically improved, actually more than requirement. And in that day, and also currently as well, the bottleneck is TiKV, storage layer. So when we try to scale out TiKV more, it leads to much better performance than currently. So we surely believe that we can scale out more for the future. However, we have another finding that deterioration in query latency. I think this is famous for the distributed databases. Due to its architecture, TiDB's latency is a little bit higher than normal, like RDB. So, but latency is stable during workload ramp up. So TiDB's capacity have more, but average latency is a little bit deteriorated. So what we need to do is to verify that whole PayPay system is able to support latency with TiDB, kind of like to be more elastic. And last verification is operational verification. This is more of the nature of distributed databases. So first of all, in terms of replication, since TiDB is distributed databases, so its replication architecture is quite different from Aura and normal MySQL. So we make a replica of TiDB and compare the data with single inspector. And another part is to address the stability. So we made a disaster recovery drill by ourselves. So we made a failure test with wallet application workload, like a component down or network partition, no easy failure in AWS. And we verified achievement of RPO and RTO, and we were able to measure impact to services, and it was improved comparing to the previous architecture. So here is a result. As a positive impact, as I mentioned, we are able to achieve the better stability, and we can confirm the mitigation of service impact during instance failure. And apart from that, we can improve the non-production environment, like as we introduce continuous data consistency check on those environments, and we got more sensitive for failures in non-production environments. With these factors, we were able to get an insight about new automated, like a reconcile and data fix system, and also it will also help us to identify the optimal retry and timeout configuration, which can be applied to existing system on the production environment. However, there is a still downside. Actually, this is not a huge problem, but select query performance. So as I mentioned, latency is larger than previous one. So we need to revisit some architecture in PayPay system, because some other system, depending on the query latency, select query latency with the previous architecture. And another one is a scalability for read-only workload. This might be a bit interesting, because in Aura, we are able to scale out read-only instances without affecting write workload. But as I mentioned, current bottleneck is storage layer. That means if there are more read workload, that impact to the write workload as well. So we are revising the architecture considering the applying cache or scaling more or things like that. But yeah, this is what we found. So by the way, if you only see this slide, or if you just need a scalable database, maybe other option might be look feasible. But we introduced TiDB not only for the scalable databases, we need MySQL compatible database, and also we need more stable databases. That's why I introduced TiDB. So since 4 years has been passed since we introduced TiDB. So finally, we are here to evaluate the result of TiDB migration. So since its launch, we still increasing number of features, and we are still growing TiDB, growing services with TiDB. So I surely believe that we can say we are able to appreciate what TiDB provide. But current architecture is not goal. There are hundreds of miles to go. There are tremendous transactions to be processed and to be committed. So we need to keep on seeking for what will be the optimal databases for the future. And this might be the next version of a new architecture on TiDB. So let me talk about the future of current TiDB in PayPay. Before going forward, I need to show current architecture with PayPay. So we have primary cluster on the left side, and we are replicating its data with TiDB WinLog, which is a TiDB component. And we have TiDB replica on the local region. And we have DR site, which is separated region. And we have TiDB replica for the regional disaster purposes. And we are taking backup on it. And interestingly, we still have Aura. This is for the OLAP workload. And also, we are importing data for the data lake from Aura. Actually, this is current our pain point. So as I mentioned, TiDB is introduced to resolve some specific problem. So all of database is not on TiDB. First one is a data lake. We have separated data lake in PayPay. So TiDB still needs to replicate data on it. So HTAP feature doesn't work for the whole business requirement. And also, Aura MySQL is majority and primary option in PayPay. So this means large part of data is not on TiDB. Then data in TiDB can play important role only on the data lake. However, we still need HTAP databases for some reason. This is why we want to replace the Aura. So first one is a data sanity check with data lake. Actually, we are trying to make sure that data consistency with data lake and its TiDB upstream cluster. But also possibility is quite small. We need to prevent a data mismatch because this is financial services. We can't be more critical about it. And another one is an aggregation job to support financial services. Actually, we wanted to run it on the data lake, but it doesn't satisfy some requirements to run financial services. And if we run it on primary cluster, as I mentioned, the current bottleneck is storage layer. So it will add additional workload on storage layer. So we wanted to apply it. So that's why we are still running it Aurora. So here is a future architecture change. So maybe since you're already here, so you might know about it. But we are replacing TiDB WinLog with TiCDC. And also, we are going to introduce TiFlash. And our AP app is heading to TiFlash instead of Aurora. But however, so this migration is not straightforward in reality, because TiDB WinLog have some good point comparing to TiCDC. So as I mentioned, current bottleneck is storage layer, or TiKV. But in TiCDC, it communicates with TiKV directly to pull the data. This means we need to have the additional workload on storage layer. Although this is small, but in TiDB WinLog, TiDB write into pump for the WinLog, and that's it. So there was no impact on the workload. And considering the operation, actually for performance test with naive one, we can just run it. But considering the TiCDC design, we need to make sure that in which case, what's going to happen. Let's say if we start replication from the last date, or if we start replication or stop it and resume it, or things like that. So to run rigorous performance test, the problem is effort and cost to set up verification environment. And we can do the same for the incremental backup as well. Because TiDB WinLog is responsible for incremental backup as well, so we need a replacement with TiCDC. So this is realized with BR2 and log backup, but unfortunately, it also needs additional workload on storage layer. So actually, what I wanted to say is same. We need to spend effort and cost to set up a verification environment, and we need rigorous performance tests to realize it. So however, I mentioned about downside of TiCDC, but there are a lot of benefits that TiCDC provides. First one is the scalability in replication performance. In TiDB binlog, replication is handled by Dorena, which is a single process. That means we cannot scale out it. But with TiCDC, it composed by several TiCDC processes as a cluster. So we are able to scale out the replication performance. And additionally, we can gain the stability and data durability in replication and upstream cluster. This is interesting. So because of this architecture, TiDB is trying to write into the pump for the TiDB binlog. This means if we lose one of type pump due to some of instance failure, binlog is lost, and data is not consistent between upstream and downstream. And also, this means that with this, in every point, we may need to restore the downstream cluster as well. And another one is that stability in upstream cluster. So by default, let's say if TiDB failed to write binlog into the pump, in that case, TiDB try to restart it so that we can prevent data inconsistency. But during this period, since TiDB will be restarted, so there is an impact to the customer. So this is not happy for the services and customers. However, TiKV directly communicated with, TiCDC directly communicated with TiKV, so we don't have to care about these issues. This is very good for the operational purposes. And also, due to its architecture, TiDB binlog doesn't support new features, although it's still not new, but asynchronous commit or things like that. So this could gain the possibility to introduce this sort of new features. Yeah, with this new architecture, I think we were able to gain enough agility and more throughput with our databases. And we are going to work for introducing TiDB new architecture on the Aura environment, and so that customers are able to gain more benefit from our services. So that's why we need you. So let me do work a little bit more. So we are located on Japan, and our engineering member have several hundred people who are from more than 50 countries, even though this is located on Japan. If you seek for opportunity to work in Japan, and if you are interested in our services, I'm talking to you. That's all from myself. Thank you. If you have any question, I'd like to answer, including hiring part as well. Yeah, please go ahead.
Okay, so I see you have a lot of verifications and tests before doing the MySQL to TiDB migration. Question I have is, do you have a rollback plan in case something goes wrong? And if so, what is it? Have you ever used it?
Yeah, thank you for your question. So actually, I showed that we still have Aura on the downstream, but originally it has a responsibility for the rollback. So if something happens, so we can promote Aura as a primary, and then application can connect to it. So that is one of the motivations. Still, we had the Aura originally.
So I presume you replicate to Aurora through TiDB binlog.
Right.
Okay.
All right. So it's fine. All right. So thank you for your time, and thank you. I'd like to say thank you for PinCap to provide this sort of precious opportunity. Thank you.